Welcome to this explainer. Today we're taking a highly technical, but honestly a really human look into how artificial intelligence is just completely transforming network defense. If you've ever found yourself wondering how security operations centers, SOCs, manage the absolute mountain of daily threats, well, you're in the exact right place. We're going to break down this incredible autonomous pipeline featuring two massive game changers, Aegis AI and Threat Oracle. Okay, let's dive into this. So, can AI prevent cascading cyber attacks? It sounds like a question straight out of a sci-fi convention, right? But actually, it's the literal spark that ignited this entire project. The creator of this autonomous pipeline was just chilling on the couch with his girlfriend, watching a popular Netflix thriller about this catastrophic nationwide cyber attack. Halfway through, she turns to him and asks, "Hey, you're good at that stuff. Can't you use AI to prevent that from happening to us?" He kind of laughed it off at first, but then he just couldn't stop thinking about it. Could an autonomous AI layer actually be the answer? By the way, the movie that sparked that whole conversation was Leave the World Behind. Now, look, a synchronized cascading takedown of our GPS, comms, and critical infrastructure, that is a fictional Hollywood crisis. But the underlying premise, the sheer vulnerability of our networks, that is absolutely a very real threat. Every single day, nation-state actors, ransomware gangs, and automated tools are out there probing enterprise networks literally millions of times. It's an overwhelming reality. The bad guys are moving at machine speed. And that brings us to the very real-world crisis happening inside enterprise security teams right now, alert fatigue. To really wrap your head around the scale of this, imagine trying to navigate the MITRE ATT&CK framework. It's this massive, ever-evolving matrix of adversary tactics. Now picture a typical enterprise SOC. These folks are handling anywhere from 1,000 to 10,000 alerts every single day. And to make matters worse, the false positive rate on these alerts routinely exceeds 50%. No joke. Analysts are just drowning in the sea of noise, which leads to missed detections and critically slow response times. The bad guys are literally counting on our human limitations. Section 1. Aegis AI, the first line. So, to combat this massive alert fatigue, we desperately need a new approach. Enter Aegis AI. Think of it as an autonomous first responder layer sitting right at the edge of your network. And it's got the technical chops under the hood to back it up. Aegis AI is powered by a multi-agent pipeline. Right at its core is the prediction agent, which is an XGBoost classifier. And get this, it was trained on 2.83 million real labeled network flows from the widely respected CIC IDS 2017 benchmark dataset from the Canadian Institute for Cybersecurity. This massive training ground is exactly what gives the AI its deep understanding of what normal, everyday traffic looks like versus a malicious attack. Because of all that robust training, the performance metrics are honestly staggering. On a held-out test set, the Aegis AI prediction agent achieves an area under the curve, or AUC, of 0.9992. Now, in data science terms, an AUC that close to 1.0 means the model is exceptionally accurate at distinguishing between benign traffic and actual threats. We're talking a 99% attack recall and a 95% attack precision. That means it rarely misses an attack, and when it does flag something, it is almost certainly a real threat. It drastically cuts down that brutal 50% false positive rate we were just talking about. Now, what's really interesting about this is how all of that complex machine learning translates directly into a real-time threat console. Instead of presenting analysts with just a giant, unreadable wall of text, the live dashboard streams events and autonomously makes triage decisions. It decides on its own whether to simply monitor an event or escalate it. It instantly categorizes attack families like brute force or DDoS and assigns a severity level from info all the way up to critical. And behind the scenes, an explanation agent is actually generating an analyst-grade narrative and a 5-step action plan for every single flagged event. It's doing all the heavy lifting of initial triage instantly. Section 2. Mapping, attack, and defense. Detecting a threat is really only half the battle. Once something is flagged, analysts face this impossible math of bridging offensive knowledge with defensive countermeasures. On the offensive side, the MITRE ATT&CK framework contains over 600 specific adversary techniques spread out across 14 different tactics. Meanwhile, on the defensive side, the MITRE D3FEND framework maps hundreds of specific defensive countermeasures back to those offensive techniques. So if a critical alert comes in, a human analyst has to manually cross-reference the offensive technique being used against them with the exact defensive countermeasure needed to stop it. And let's be real, no single human being has all of that memorized. And this brilliantly illustrates just how massive of an undertaking this is. Manually navigating between these two giant knowledge graphs, ATT&CK for offense, D3FEND for defense, during an active, high-severity incident is painstaking. For an expert, cross-referencing these takes anywhere from 15 to 45 minutes per incident. When you have thousands of alerts, that math simply doesn't work. By the time an analyst figures out the exact right countermeasure to deploy, the attacker has already moved laterally through the network. They're gone. Section 3. Threat Oracle. Instant Intelligence. This right here is exactly why the second half of this pipeline was built. Threat Oracle AI is the intelligence layer, and it's designed to completely democratize expert cybersecurity knowledge. The way these two systems connect is through this very deliberate, seamless workflow called the Intelligence Bridge Handoff. It's incredibly straightforward. When Aegis AI flags a high-severity or critical event, the human analyst simply selects that event and copies its raw JSON payload. This payload contains everything Aegis AI knows: the attack family, severity, risk score, and that LLM-generated summary. Then, the analyst takes that JSON and just pastes it directly into the input window of Threat Oracle. Boom! The absolute second you hit Analyze, Threat Oracle goes to work. Using a hybrid retrieval system connected to a massive database of MITRE frameworks, Threat Oracle synthesizes the data and generates a full threat diagnosis report. It gives the analyst a clear executive summary, ranks the suspected ATT&CK tactics by confidence, maps out the exact D3FEND countermeasures needed, and provides a prioritized remediation plan, all fully cited, by the way. Basically, Aegis AI tells you something is wrong, and Threat Oracle tells you exactly what it is, who does it, and exactly how to stop it. So the crucial point is the time compression. We established earlier that manually cross-referencing the ATT&CK and D3FEND frameworks can take an expert up to 45 minutes for just a single incident. But by pasting the Aegis AI detection data into Threat Oracle, that entire manual intelligence gathering process is compressed into under 15 seconds. Think about that. 45 minutes down to 15 seconds. That is literally the difference between a quickly contained incident and a catastrophic data breach. Section 4, the future of SOC. Let's move to and see how this builds together. What makes this specific pipeline so incredibly powerful is its loosely coupled architecture, meaning it can accept data from any upstream detection system. This completely reshapes our modern defensive posture. We've evolved from an era of purely manual alert investigation, where analysts suffered from crushing alert fatigue and impossible math. Then we moved to the integration of autonomous detection, using tools like Aegis AI to filter the noise and find the real threats with machine learning. And now we've arrived at instant intelligence, utilizing systems like Threat Oracle to instantly map those detections to exact framework-backed defensive actions. Which brings us right back to the couch and that Netflix movie, Leave the World Behind. Could this pipeline have stopped a massive, coordinated nation-state attack on national critical infrastructure? Well, probably not entirely on its own, but for the 99% of complex, automated threats that hit enterprise networks every single day, absolutely. So leave you with this. Is this AI pipeline the autonomous first responder layer that modern SOC teams absolutely must have to prevent the cascading attacks of tomorrow? Based on the impossible math of alert fatigue, I'm going to say the answer is a resounding yes. It turns out the creator's girlfriend hit the nail on the head all along. Thanks for joining me on this explainer. Keep learning and stay secure.
So this is Aegis AI, which is part of a Security Operations Center pipeline in addition to Threat Oracle AI, which I'll show you in a minute. This is the real-time threat console working away. You can see the threat trend over the last 10 minutes. Live event feed of all the events. IPs are 0.0.0.0 because it's a test data set. In real life, we'd have the actual IPs there. And some event detail. If I was an SOC analyst, I'd probably go to the Explorer page and say, all right, what do I need to be concerned about? Let's take a look at critical issues. Some DDoS, brute force. Okay, let's take a look at only brute force. Oh, there's one. Okay. Take a look at that guy. And so I want to drill down into this. Let's copy the brute force. And usually what would happen is you'd have to go to MITRE ATT&CK and then figure out what techniques they were using and what sub-techniques, and take a look at this monolithic wall of text to figure out these techniques. And then we go to the defend matrix and take a look at another monolithic wall of text and figure out with our skill set what was being used and how we can defend against it. It takes a lot of time, 30 to 45 minutes just on one attack. Instead, what we're going to do is go to Threat Oracle, paste the logs in that we copied, maybe add a few things, maybe say website is slowing, maybe say some logins are compromised. And then click Analyze. And now what it's doing is it's normalizing our input, and we've actually ingested all of the MITRE ATT&CK and MITRE DEFEND techniques, the entire database, which is huge. And now we're using an LLM in the background with a RAG-based database to match off what the attacks were and the defenses were. And inside of 30 seconds, we've got a threat diagnosis report saying our systems have detected a high severity incident involving widespread brute force attempts targeting critical services like FTP, etc., etc. And the techniques right off the MITRE ATT&CK grid are password guessing, brute force, password spraying, credential stuffing, valid accounts, modified authentication process, FTP, endpoint denial of service, etc., etc. And it gives you the recommended immediate actions, containment, network filtering, service hardening, enhanced monitoring, forensic investigation, and then an attack chain assessment to pass up the chain and also put in your logs. So basically what we've done is we've taken a security operations center pipeline and reduced the time involved from, say, 45 minutes down to 30 seconds. Thanks very much.